November 2837 uniform.
Proceed via the 12.5 mile DME ARC.
Northeast of Paso Robles. Intercept the final approach course. Maintain 5,000. DME ARC.
So now you know why they don't let dentists be air traffic controllers, but let you and I talk about flying DME ARCs. Now, some pilots do have real difficulty with them and consider them a great big pain, kind of like an aviation root canal. But flying a DME ARC is really a simple procedure if you look at it one step at a time. So let's assume you're flying inbound to the Paso Robles vortex on the 077 degree radial, and you're approaching Jebno here, and you're actually on a heading, of course, of 257 degrees, and you've got actually 257 also set in the OBS. Now notice Jebno is the 12.5 DME fix from Paso Robles. Now in this case, let's assume that when we get to Jebno, what we're going to do is follow the arc to the south and fly it clockwise around the station. And that will start us on this approach right here, in which we will intercept and follow the 313 degree course to the airport. Now the first thing to figure out is how to enter the arc going in the direction that you want around the vortex. So you'll be turning to the right in this case. So if you're inbound to the vortex, your initial turn to get on the arc will actually be the opposite of the direction you'll be turning to stay on the arc. So if you're flying clockwise around the station, you'll be turning to the right when you get on the arc. So on the arc, you'll be turning to the right. But as you approach the arc inbound to the station, your initial turn then will have to actually be to the left. Now, before you get to Jebno, you want to reset your OBS to put 257 at the bottom of the indicator, and then 077 will be at the top. And that way we'll start flying the arc with reference to the 077 radial from the station rather than the 257 course to the station. That makes it easier to visualize what you're doing. Also, it's easier to think of your progress along the arc in reference to radials from the vortex rather than courses to the station. Now, once you have reset the OBS to the radial you're on, you'll no longer be following the needle. Your course will now be defined by your DME position from the station as you turn the arc to the right. So now as you approach the arc, you'll need to lead your turn to intercept that arc. The amount of lead you need depends on your ground speed. The faster you're going, the more you need to lead that turn. A good rule of thumb is to lead the turn by 1% of your ground speed. So if you're going 100 knots, you'll need to start your turn about a mile before you get to the arc you want to be on. Now, as you approach the arc, so what you need to do is hold your heading until you get to that lead point. So in this case, the lead point is going to be at 13.5 DME. That's 1 mile before the 12.5 DME arc. So as we get to 13.5 miles, we will start our left turn to put our previous heading of 257 just a few degrees ahead of the right wingtip. Now, one technique that you can use to help stay on the arc once you've gotten yourself established on it is what's called turn 10, twist 10. So you start off by holding your heading and monitoring the DME to see that you're staying on the arc. Now, once you are on the arc, you'll want to set the OBS 10 degrees further along. So in the direction of your arc. So in this case, you'll set it to the 087 degree radial. And every time the needle centers, you're going to get an update on your progress around the arc. So when the CDI centers, you need to turn 10 degrees to the right in the direction of the arc, in that case to the right, and reset the OBS to a radial 10 degrees further along the arc. Now, when the CDI recenters, that tells you it's time to turn 10, twist 10 again. And you keep repeating the same process as you proceed around the arc. So you can see why they call this technique turn 10, twist 10. Now, as you can see, if you follow this procedure exactly, you're going to actually be flying 10-degree straight lines around the arc. But in reality, you're going to be watching your DME to see where you are in regard to the arc. And you may want to turn more or less than 10 degrees. So if you have gotten outside the arc, you need to turn more than 10 degrees to get closer to the station. So to get closer to the station, you need to put the right wingtip slightly behind the station. And to get further away, you put the right wingtip ahead of the station. Now, a simple way to do that is just hold your heading until you're back on the arc. Now, let's say you get yourself, say, a half mile or a mile off the arc. The largest correction you need to make is about 10 to 20 degrees. Now, just as we needed to lead our turn to intercept the arc, we also need to lead our turn to intercept the inbound course. Now, when the course inbound will be a localizer, the approach charts actually show a lead radial. But on a VOR approach, the needle is a lot less sensitive, and a lead radial is not really necessary. So one isn't shown on this approach, for instance. So you can still figure out, using 1% of your ground speed, what the lead needs to be. Now, just like we did here to get on the arc. Now, the trick is to figure out how many miles each degree of arc is. Now, basically, what you need to do is remember that if you want a 1 mile lead, as you would in this case, the further you are from the station, the more miles each degree of arc will be. That's because when you're on the 60 DME arc, each mile is equal to 1 degree. But as you get closer to the station, each mile is more than a degree, and the needle swings faster as you approach the radial. So the easiest way to judge your lead for a turn is to watch the rate of needle movement as you approach the course. So in this case, we're on the 12.5 DME arc, and let's see what to expect as we lead our turn. So we'll round that off and make it 12 miles. So if you divide 60 by the DME distance, in this case we'll call it 12, it'll give you an idea of how fast your needle will swing. So for instance, on the 12 DME arc, the needle will swing 5 times as fast as it would on the 60 DME arc. So now notice the course inbound to the station is 313 degrees. So the reciprocal of that would be about 133 degrees. So as we progress around the arc to say the 123 degree radial, we should set the inbound course of 313 degrees on the OBS. So we need to start our turn to follow that 313 degree radial about 5 degrees in advance. So as you remember, on a VOR, a full needle deflection is 10 degrees. So when you get to a half scale needle deflection, what you want to do is start your inbound turn. Now, the reason we had to do all of this twisting and turning was we didn't have an RMI to help us out. If we did, it would have been a lot easier. Now, most glass cockpits will make a radio magnetic indicator, or an RMI, available to you. So let's take a look at what flying a DME arc would be like with an RMI. Now, as you remember, an RMI is a heading indicator with a needle that also points the bearing to the station. So with an RMI, flying a DME arc is a piece of cake. Now, in a no-wind situation, all you have to do is keep the bearing pointer straight off the right wingtip, and it'll be pointing right to the station. If you're going to the left, it'll be left wingtip, but for a right wingtip, for a right DME arc. Now, you can fly a nearly perfect DME arc with an RMI with just occasional glances at the DME indicator. So, for instance, if you're flying a right-hand DME arc like we are here, all you'd have to do is, you're flying a right-hand circle around the vortex, all you have to do in a no-wind situation is keep that needle bearing pointer right off the right side of the indicator, pointing right to the station. It'll be off the right wing of the airplane. So if you do that, you can track so beautifully around the DME arc, your air traffic controller will weep with joy. But what if you have a wind? No big deal. It's just like if you have a wind in the traffic pattern. You have to correct for it. So let's give us a wind from the right. Now, if you've got a wind from the right and you're flying a DME arc to the right, so what you want to do to stay on the arc and not get blown off to the side is crab the aircraft. And so you're going to have to crab into the wind. Now, the wind is from the right, so the airplane is going to have to crab to the right in order to compensate for that wind and stay on the DME arc. And when you do that, notice the position of the bearing pointer becomes just ahead of the right wingtip. And it's still pointing to the station, but the airplane's crabbed, so it's a little ahead of the right wingtip. Now, let's take a look at an instrument departure out of Medford, Oregon. So here we are looking at the departure procedure, and it says that we need to fly that departure procedure with a DME arc in it. So let's take a look at the DME arc as you fly that departure procedure. Now, here's the Rogue Valley Vortex, and notice this is a 15 DME arc. So you're flying a right-hand DME arc with the vortex station off the right side of the airplane. So far, so good. But this time you're going to have a left crosswind. Now, the question is, where will the bearing pointer need to be relative to the wingtip to stay on this arc with a left crosswind? Well, we've drawn out the basic situation we're working with here. We're still flying a right DME arc around the station, and this time with that left crosswind, we're going to have to crab the aircraft to the left in order to stay on the arc and not be drifting off of it. And that's going to move the bearing pointer behind the right wingtip in order to stay on the arc with this crosswind. So as you can see, an RMI is a great tool for flying a DME arc.